Yeah, good afternoon students. I am Dr. N. Srinivas, working as an associate professor in JNIT EC department. Today I am going to explain the topic is BJT. So BJT means bipolar junction transistor. So bipolar junction transistor. So what is meant by bipolar junction transistor? The operation depends on both the interaction of both the polarities like majority carriers and minority charge carriers. The passage of charge due to both the majority and minority charge carriers, and hence it is called as a bipolar junction transistor. What is meant by bipolar junction transistor again? So a bipolar junction transistor is consisting of two junctions like input junction and output junction. So here why it requires input and output junction? For example, if you take diode, a PN junction diode is a unipolar junction diode. So therefore the passage of current, it allows the flow of current through it is only in one direction, that it is in forward bias direction, but it is not in reverse direction. So therefore any diode does not allows the passage of current through it is in reverse direction. So therefore to avoid, so therefore we need a bipolar junction transistor. A transistor means is a three-terminal semiconductor device. Three-terminal semiconductor device. So it can transfer of resistance from low path resistance to high path resistance is called as a transistor. So therefore here the types of we have two types of transistors. So number one is the NPN transistor and PNP transistor. So in NPN transistor, what is the operation of NPN transistor? Here NPN transistor means the terminals of the NPN transistor is emitter, base, collector. So therefore the base terminal, the NPN transistor means the base, the P material is sandwiched in between the lightly doped two N-type semiconductor bars is called as an NPN transistor. But a PNP transistor, the base, the N terminal, N silicon or germanium is sandwiched in between the two P-type semiconductors is called as a PNP transistor. Now, what is the NPN and PNP transistor? Basically, NPN or PNP transistor is a back-to-back two diode connections. Back-to-back two diode connections. So therefore, one terminal is P, another one is N. Again N and P. So therefore, back-to-back. So one is called as a forward bias PN junction diode and another one is called as a reverse bias PN junction diode. So this is called as a back-to-back two diode analogy. So already we know that what is PN junction diode, forward bias PN junction diode. So therefore, for example, if you take PNP, so any EBC means the emitter base collector. The emitter is base is a lightly doped terminal, emitter is a heavily doped terminal, and collector is a moderately doped terminal. Now what are the operating regions of a transistor? It can operate, operating regions of transistor is cutoff region and active region, saturation region. So in cutoff region, the junctions should be, so therefore the ENP junction, so for example it is having two junctions, say for example it is -2 forward bias and forward bias. So therefore this is called JE1 and JE2. So therefore it is a three-terminal semiconductor device, emitter, base, collector, and two junctions JE1 and JE2. So therefore the operating regions of transistor, any transistor is cutoff region, active region, saturation region. In cutoff region, both the junctions should be in reverse bias, means OFF are 0 volts, and in active saturation region means both the junctions should be in forward bias. Like JE1 and JE2 are in cutoff region, both are reverse bias. In saturation region, both the junctions should be in active region, saturation region. In active region, one JE input junction must be forward bias and output junction must be in reverse bias. So therefore these are the operating regions of transistor. Operating region of transistor. So therefore in cutoff region, both the junctions JE1 and input junction and output junction must be in cutoff reverse bias. In saturation region, JE forward bias and collector junction, reverse junction is will be forward bias. In active region, input junction must be in forward bias and reverse output junction must be in reverse bias. Now what are the transistor applications? or current components of transistor. Say for example, if you take NPN or PNP transistor, PNP transistor, so therefore the circuit symbol representation of NPN transistor is, so this is emitter, base, collector, NPN. Here the arrow indicate outward. So therefore the flow of charge carriers are flows across this emitter terminal. So therefore this, for example, the arrow indicates inward, it is called as a PNP transistor, or of two types, NPN transistor and PNP transistor. So this, what are the applications of transistor, how a transistor can be used, where it can be used. So therefore transistor used as a switch. The transistor, how the transistor can be used as a switch. It can be used as a switch, like closed circuit switch, and number two is an amplifier. When does a transistor can be used as a switch? So according to operating region of transistor, it is switching from cutoff region to saturation region. See, for example, if you take any output characteristics of any transistor configuration, here I am taking the output characteristics of CE amplifier or CE transistor. So IC versus VCE, keeping IB as constant. So this is IB is equal to 40 microamperes, 20 microamperes, and 10 microamperes, and 0 microamperes. The operating regions are, here it is saturation region, and it is active region, and this is the cutoff region. So in saturation region, both the junctions should be in forward bias, and active region, one junction is in forward bias and another junction is in reverse bias. Whereas in cutoff region, both the junctions should be in reverse bias. Based on its Q point, what is Q here? The center of IC comma VCE maximum. Where when does we can get IC is equal to VCC by R, CR, RL. So therefore the Q point, what is mean by Q point, or operating point of any device? So therefore the Q point is defined as, in order to get proper DC values or proper amplification, the Q point must be in active region. In order to get on distortion less amplification, it has to satisfy two conditions. Number one condition is the transistor is always operated in active region. And number second condition is all its parameters like VCC, IB or VCC, alpha, beta, gamma within the range. Then only we can get a distortion less amplifier. So for example, the Q point may not be stable. The Q point is not at center. So therefore you may get distorted output. In order to avoid distortion less, in order to get distortion free amplification or distortion less amplification, it has to satisfy two conditions. Number one is the transistor is always operated in active region, and all its parameters like alpha, beta, gamma, anything, all will be within the range. Generally you can get distortion less amplification. So therefore the Q point you can take center of this IC comma VCCE. So therefore you can get the maximum the distortion less output. So this is when does the applications of transistor, it can be used as a closed circuit switch. When does it can be used as a switch, closed circuit switch? See, for example, the transistor is switching from cutoff region to cutoff. Let us say saturation means say plus 5 volts representation, cutoff means 0 volts. Now the transistor is switching from saturation region to cutoff region. So therefore if it is a 5 volts, say for example ON on, if it is a 0 volts means OFF off. Now the switch is fully on or fully off. So therefore it is moving from cutoff region to saturation region, it will be act as a closed circuit switch. And number two is when does it act as an amplifier? When does it used as an amplifier? So in between saturation to cutoff region there will be an active region. In this region you can get the maximum signal amplification, voltage swings or current swings or what out may be. If your Q point is proper or in center or at middle point, so therefore you can get the maximum amplification levels without any distortion or distortionless amplification. So therefore at this condition any amplifier, any transistor can be used as an amplifier. So therefore these are the two transistor can be used as a switch and used as an amplifier. Now based on this transistor, there are three types of configurations. So there are three types of configurations. So what are the three types of transistor configurations means? Common base, common base transistor configuration and common emitter transistor configuration, common emitter transistor configuration and common collector transistor configuration, common collector transistor configuration. So based on the types of transistor configurations are 3: CB, CE and CC. So why we require 3 types of transistor configurations? So in order to, by using these 3 we can find its input and output characteristics, of transistor. So how we can determine or how we can find the transistor characteristics, input and output transistor configurations. For example, if you take any CE or CB or CC transistor input and output transistor configuration characteristics. For example, here common emitter configuration, transistor configuration. So here common emitter means the common emitter terminal is made grounded for input as well as output. See, the circuit diagram for common emitter configuration is here emitter is made ground for input as well as output. So this is output junction VCC. So this is emitter, base, collector. So the output here the output current IC current will flows from output junction side, and the output junction is VCB, and input junction voltage is VCB, VEB or VBE, and the output current is IB, RB. This is the VBB. So this is the ground. The emitter is connected to ground. This circuit is used to find input and output characteristics of common emitter configuration. So how to find input characteristics for CE configuration? So therefore in CE, what are the input characteristics? IB versus VBE, keeping output VCB as constant. See, for example, IB versus VBE, keeping VC as constant. So in order to determine input characteristics of CE transistor, the first step is we need to set VCE is equal to 0. VCE in output junction keep or set VCB is equal to 0, and by varying VBB input junction voltage. So therefore you need to note it down, IB versus VBE. So in this junction the diode becomes in forward bias direction. So therefore what happens here, when VBE is greater than Vin, so therefore its cut-in voltage of the transistor, so automatically the transistor becomes on. So once it becomes forward bias means the IB gets increases. So therefore at 0.3 and 0.7, if it is the transistor is made up of silicon, its cut-in voltage V gamma is equal to 0.7 volts. If it is made up of germanium material, the cut-in voltage of this transistor is 0.3 volts. So therefore if you increase your V in, so as and when reaches 0.3, when VC is equal to 0, then the current starts increases at from 0.3 to 0.7. If it is say 0.3 volts or it is a 0.7 volts, so therefore then the current starts increases at VC is equal to 0. And again repeat the steps when VC is equal to greater than 0. So therefore as your input voltage increases, the current will increases maximum, whereas in the minimum voltage is cut-in voltage, VF forward bias voltage cannot be exceeds, even if increase your applied voltage more than 30 volts, but it cannot exceeds 0.3 and 0.7 voltage, because the minimum voltage is required to turn on the device is only 0.3 or 0.7. But if you goes on increase your applied voltage, the space charge width or depletion charge width, the forward junction width will be gets reduces towards 0. It is narrower because it cannot exceeds 0.3 and 0.7 voltage. Even if you increase your applied voltage more than 30 volts or 35 or 40 volts, but it cannot exceeds because it is the maximum allowable forward bias voltage is only 0.3 or 0.7, whereas the current is maximum. These are the forward bias characteristics of transistor. So what are the RB is equal to minimum, the characteristics of forward bias, the IB forward current is equal to maximum, and the VF, that is called cut-in voltage, is equal to minimum 0.3 or 0.7. The space charge width of the forward bias junction gets decreases as your applied voltage increases. This is called as a forward bias input characteristics of CE transistor configuration. So therefore, the first step is, in order to get to determine input characteristics of CE transistor configuration, first we need to set VC is equal to 0. And by increasing VBB, you have to note it down IB and VB values. So then the step is increases, and you have to set another value, that is called more than VC is greater than 0 or 1. Next VC is equal to forward greater than or 2 or 3 or whatever it may be. So this is, in this way we need to calculate or find the input characteristics of common emitter configuration. Now how to calculate output characteristics of CE transistor configuration? So to find the output characteristics of CE transistor configuration. So therefore, the output characteristics of CE is IC versus VCE, keeping IB as constant. IB as constant. Here IB is equal to 40 microamperes, 20 microamperes are different higher fixed values of IB. So IC in milliamperes. In order to find the output characteristics of any CE transistor configuration, first we need to keep IB is equal, in input side you need to set or keep IB is equal to some value constant, and by varying VCC output junction voltage you need to note it down IC value and VCB value. So therefore, for different constants of IB is equal to 40 microamperes, 20 microamperes, 10 microamperes or 0 microamperes. So therefore, this is in order to find the output characteristics of CE transistor configuration, first you need to fix IB has to be set or keep IB is equal to some 0 or 10 to or whatever it may be. Then while increasing output junction voltage, note it down IC versus VC values. So therefore, this is called as an output characteristics transistor configuration. So for this you need to find its current gain parameters like alpha, beta and gamma. For alpha is used for the current gain parameter for common base configuration, and beta is used for common emitter, and gamma used for common collector current gain parameters. This is current amplification factors. So therefore, this is output characteristics and input characteristics of common emitter. If it is a common base, the base terminal is made grounded for input as well as output. If it is a common collector, the collector terminal is grounded for input as well as output. So common base, common emitter, common collector. We have three types of transistor configurations. So for example, the Q point, why we need Q point for any device? Q point or operating point. So if operating point, Q point of the device is not stable or not set at middle or center of the curve. So therefore, what happens here? So as we know that, so in order to avoid thermal runaway condition, so what is meant by thermal runaway condition? For every rising of 10 degree temperature, the reverse leakage current in the transistor IC naught, if it is a CE amplifier, IC naught, the reverse leakage current would becomes double. The double becomes cumulative. This cumulative process leads to destroy the transistor, and hence this process is called as a thermal runaway. In order to avoid thermal runaway, so therefore the Q point has to set the in active region. If it is not in active region, so therefore there is a chance we will get distorted output. In order to get distortionless amplification, so therefore the Q point must and should be operated in active region. Otherwise, if any parameter, transistor parameters, if VCC may change, IC may change, IB may change, or whatever may be. So therefore all these parameters are current temperature dependent parameters. If any one parameter may change, so therefore the reverse, the thermal runaway may occur. So if the thermal runaway means for every rising of 10 degree temperature, the reverse leakage current in the transistor, in the diode IS, in the transistor IC0 will becomes double. The double becomes cumulative. This cumulative process leads to destroy the transistor. So therefore, and hence this process is called as a thermal runaway. In order to avoid the thermal runaway condition, so therefore the Q point has to be set properly. So therefore, if not, what happens? Thermal runaway, there will be occurrence of thermal runaway condition. So to avoid a thermal runaway, so therefore the Q point has to be set in middle. This is the concept of transistor and types of transistors and types of configurations and applications.